Hello and welcome once again mga Lodi sa ating channel. Today we will learn how to get the inverse of a one-to-one function and how to restrict a function if it's not a one-to-one relation. So, stay tuned. Now let's define what is a one-to-one function. A function f is one-to-one if it never takes the same value twice, or f of x sub 1 is not equal to f of x sub 2. Whenever x sub 1 is not equal to x sub 2. That is, the same y value is never paired with two different x values. Another way of identifying one-to-one relation is by using the graph. So if f is a one-to-one function, then no 2 points x sub 1, y sub 1, and x sub 2, y sub 2 have the same y value. Therefore, no horizontal line cuts the graph of the equation y equals f of x more than once. So for example, let's compare the graphs. So on the first graph, we have a linear function. Now let's use the horizontal line rather. So as you can see, we have one value for y paired with one value for x. So if this is our graph, therefore we can say that the graph is a one-to-one function. Another one. So we have the graph of a parabola, which is y equals x squared minus 2x minus 3. Let's use our horizontal line. Now, as you can see, we have one value for y, but it paired with two different values for x. So in this case, it's not one-to-one relation. Now, if the graph is not one-to-one relation, we can still find its inverse by using its restriction. Since we know what is a one-to-one function, then we can find its inverse. To find inverse, we have f inverse of x, express the function in the form y equals f of x. Number 2, interchange the x and y variables in the equation. Number 3, solve for y in terms of x. And then number 4, replace the new y with f inverse of x if the inverse is a function. Now let's have an example number 1. F of x equals 5x minus 5. So first is to replace f of x with y. And then just copy the function, 5x minus 5. And then next is to interchange the position of x and y. So y becomes x, and then x becomes y. Then we will solve for y. So we will simply move this number on the other side so that we can have x plus 5 equals 5y. And then we can now simply divide both sides by 5 so that our final answer is y equals x plus 5 divided by 5. Since this is our new y, we can now change into the inverse function. We have f inverse of x equals x plus 5 over 5. And this is our inverse of the function f of x equals 5x minus 5. Now let's take a look on our example number 2, which is a rational function. So f of x becomes y equals 3x plus 3 divided by 2x minus 2. Okay, so let's interchange x and y. So we have x equals 3y plus 3 divided by 2y minus 2. And then simply cross multiply to get the answer of x times 2y minus 2 equals 3y plus 3. And then we will simply distribute x inside the parentheses. So we have x times 2y, we have 2xy. X times negative 2, we have negative 2x. And then equals 3y plus 3. And then we will combine like terms. We will transfer 3y on the other side and then 2x on this side. So let's do that. We have 2x y minus 3y equals 2x plus 3. Okay, and then we combine like terms. We factor out y on this side. So we have y equals 2x minus 3 equals 2x plus 3. And we can divide both sides by 2x minus 3. And then we will just simply left with y equals 2x plus 3 all over 2x minus 3. Since we have our new y, we can change that into our inverse function, which is f inverse of x equals 2x plus 3 all over 2x minus 3. And this is the inverse of our function number 2. Now let's have number 3. F of x equals x plus 3. So by analyzing our function, this is a radical function, or also known as one-sided function. So this one has already a restriction. So let's find that. So the basic idea is to make the number inside the radicand 0. So we have x plus 3 equals 0, and then x becomes negative 3. If we're going to graph this function, so x is equivalent to negative 3, and that would make the radicand 0. And if we're going to graph that, say for example, let's use negative 4 plus 3 inside the radical number, the expressions becomes an imaginary number. So we are not allowed to have a negative number inside the radicand side. So since negative 4 is not included, we are restricted to that. So the functions will simply look like this on the graph. So this is just a rough sketch. You can try to graph that one on our different applications. So therefore, the restriction for number 3 is x must be greater than or equal to negative 3. And then since the function grows from the x-axis, therefore the range is y must be greater than or equal to 0. So we will use these two information to graph the inverse of number 3. Let's proceed to that. So we have this function. Let's now take the inverse of this function. We have y equals the square root of x plus 3. And then interchange x and y. So we have x equals the square root of y plus 3. And then simply get the square or square both sides. We have x squared equals y plus 3. And then simply move number 3 to the other side. So we have x squared minus 3 equals y. And then, since we already have a new y, we can now put it back into our inverse function. F inverse of x equals x squared minus 3. Okay, since we put a restrictions to our original functions, which is x must be greater than or equal to negative 3, and y must be greater than or equal to 0. Now, to restrict this function so that we could make an exact representation of its inverse, we can restrict also this one. So since this is its inverse, x becomes greater than or equal to 0, and your y restriction becomes y is greater than or equal to negative 3. As you can see, its inverse for this restriction is also the inverses of one another. Okay? And this is the inverse of our example number 3. Okay, so let's take a look on our example number 4. We have a parabola. F of x equals x squared minus 4. If we will graph this function, so say for example, we have this graph. All right. So the vertex is simply located at 0, comma, negative 4. If if you're going to use your application, Desmos or GeoGebra, we can have a similar graph just like this one. So if we're going to take a look on this one, it will fail the horizontal line test. So with that, we need to have a restriction so that we can still use the inverse of this function. So let's restrict, for example, let's remove this one, okay, this part. So our restriction could become x must be greater than or equal to 0, and then our range must be y must be greater than or equal to -4. Okay, so with that, we can now erase our graph and then find the inverse of this function. Okay, so let's apply the methods that we used. Y equals x squared minus 4. And then interchanging x and y, we have x equals y squared minus 4. And then move 4 to the other side. That becomes y squared equals x plus 4. And then just simply square both sides. We have y equals the square root of positive negative square x plus 4. And then to make this one as exactly the inverse of this function, we now have to simply restrict this one. So we have f inverse of x becomes square root of x plus 4 if we have the restriction that is equivalent to x must be greater than or equal to -4. Sorry for that. So let's rewrite that. So x must be greater than or equal to -4, and y must be greater than or equal to 0. To consider that this inverse is exactly the inverse of that function with restriction. Okay? Okay, so for our example number 5, we have f of x equals 2 over x squared minus 2. You may pause the video and check the graph of the function. So similarly, it will look like this one. Although this is just a rough sketch, but if you're going to compare it using the graph that you use, okay, we will have a similar graph like this one. So for this example, I will be using the positive side of the domain, since this will simply not pass the horizontal line test. So let's restrict this one using the positive side only. And now we have a restriction which is x greater than or equal to 0. Now to find the restriction for y, we are going to use the method that we apply on finding the domain and range. So let's find the range. Y equals 2 divided by x squared minus 2. And then simply multiplied, cross multiply, we have y equals x squared minus 2 equals 2, and then distribute the number. We have x squared y minus 2y equals 2. And then we're going to move this one on the other side so that we will have x squared y minus 2y minus 2 greater than or equal to 0. This is the method that we use in finding the domain and range of the function. So since we have this one, we cannot simply factor this one using completing the square. So we will be using the discriminant instead. So the formula for the discriminant is b squared minus 4 times ac. So let's identify all these coefficients a, b, and c. So for the value of a, we have y. And then for the b value, we have 0. And then for letter c, we have negative 2y minus 2. And then let's find the discriminant of the value x squared y minus 2y minus 2. So we have b squared, which is 0, minus 4y times c is negative 2y minus 2. And then simply distribute this number, negative 4y, inside the parentheses. We have 8y squared So negative 4y times negative 2 is 8y. And then we have to factor out common terms, which is y, or 8y. So let's move that out. So we will just simply remain with y plus 1, greater than or equal to 0. So we have two values. We have 8y greater than or equal to 0, and then y plus 1 greater than or equal to 0. Let's continue. If we take a look on the graph, we may have an idea which are the part of the solution for the range. So since we have the domain which is greater than or equal to 0, now for the range, we're still evaluating these values. We have 8y greater than or equal to 0. Divide both sides by 8. So we have y is greater than or equal to 0. And then same goes with y plus 1 greater than or equal to 0. And then just simply transfer positive 1 to the other side. We have greater than or equal to negative 1. Now, let's have a test value from where we can find the range of solution we can get from testing these ranges. So let's start from 1, 0, negative 0.5, and then negative 1. And then from our number line, we will see which we can get our solution. Okay, so negative 1, 0, negative 0.5, and then negative 1. Okay, so let's test the value for y equals 1. So we have 1 equals 2 over x squared minus 2, and then multiplied both sides by x squared minus 2. We have x squared minus 2 equals 2, and then transfer this to the other side. We have x squared equals 4, and then the square root of 4 is just simply 2. So we have the solution for 1. So that's part of the solution. How about 0? If x is 0, so let's erase this one. So if y is 0, so that is 2 over x squared minus 2, and then cross multiply, that is 0 equals 2. So therefore 0 is not part of the solution. So we will exclude that one. And then how about 0.5? So let's substitute this value. 0.5, negative 0.5 equals 2 over x squared minus 2. And then we have 0.5, negative 0.5 times x squared minus 2 equals 2. So our answer is negative 0.5 x squared plus 1 equals 2. Okay, 0.5 times 2 equals just simply 1. Okay, and then simply move this one to the other side. We have 0.5, negative 0.5 x squared equals 1. So since 2 minus 1 is simply 1. And then divide both sides by a negative number, 0.5. And then x squared equals the square root of 1 negative 1 over 0.5, which is an imaginary number. So 0.5 is also excluded. How about 1? Okay, we have quite a mess here. So let's clean this one first before we proceed with our final solution. Alright, so let's replace 1. We have check for this value x and then x this one. So we have the final number. Negative 1 equals 2 divided by x squared minus 2. Okay, so same, negative x squared plus 2 equals 2. And then move this one to the other side. We have negative x squared equals 0, and then divide both sides by negative 1. So x squared is equal to 0 divided by negative 1 is 0. And then if we squared 0, it's also 0. So we have an answer for this one. So that means our solution, since we have this value, y is greater than 0, we cannot include 0 on our solution. So we have y must be greater than 0, but less than or equal to, since negative 1 is included, it's less than that value, we're going to get also that one. So we have negative 1. So we have the range x greater than 0 and y is greater than 0 and less than or equal to negative 1. Okay? Now we can proceed now with... Okay, so let's continue. F of x is equal to 2 over x squared minus 2 with the restriction x greater than 0 and y greater than 0 but less than or equal to negative 1. If you're still confused with the restriction, you may refer to the graph so that you can confirm that our answer for the restriction is correct. So let's change f of x into y equals 2 over x squared minus 2. And they're interchanging x and y. We have x equals 2 over y squared minus 2. And then cross multiply. So x times y squared minus 2 equals 2. And then simply distribute x inside the parentheses. We have x y squared minus 2x equals 2. And then we can move negative 2x to the other side so that we can isolate y on the other side. So we have x squared, xy squared rather, equals 2x plus 2. Then we can divide both sides by x. We have cancelled that one. So y squared equals 2x plus 2 over x. And then we can simply square both sides so that we will simply left with y equals the square root of 2x plus 2 over x. And then since we have a new y, we can replace that using an inverse function. F inverse of x equals the square root of 2x plus 2 over x with our restriction that is the inverse, exact inverse of our original function. X, so let's rewrite that once again. So x must be greater than 0 but less than or equal to negative 1, and y must be greater than or equal to 0. And this is our inverse for the function with the restriction given. Okay? Now let's proceed with the final example. Okay, so for number 6, we have f of x equals x cubed plus 2. So change f of x into y equals x cubed plus 2. And then interchange y to x. We have x equals y cubed plus 2. And then simply transfer this number to the other side. We have, and then let's rearrange this value. Y cubed equals x minus 2. And then to remove the exponent for y value, we have to simply get the cubic of each term. So simply remove this exponent. Y is equal to the cube root of x minus 2. And since we have a new y, that would become our inverse function. The f inverse of x is equal to the cube root of x minus 2. And this is our final answer for our last example. Okay, so once again, thank you mga Lodi sa pagpapanood sa atin pong video lessons. And I hope na may nakuha kayong may natutunan kayo sa ating discussion for today about inverse function. So see you again on our next video. Bye-bye. God bless.